All right, so we're going to start with 3 problems here to prepare for our assessment that deals with naming and drawing structures and shapes if we're dealing with molecules. So our first one we have is NO2 negative. So this tells me it's a polyatomic ion. And if I look on the periodic table, it is nitrite. Okay, so with nitrite here, we know that this is an ion, but these two guys are currently sharing. Nitrogen and oxygen are both nonmetals. They are sharing their electrons, so they're going to covalently bond. So nitrogen has 5, oxygen has 6 times 2 is 12, and then this means I'm taking one more. All right, so we've got 18 electrons, which is 9 pairs. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, and 9. There's my 9 pairs. However, notice nitrogen's not happy. He only has 2, 4, and 6. So we make it a resonance structure, showing that can be in both places. And I'm just going to move that so it looks better. Put it in brackets and show that we took 1 electron to make this to happen. So this is a resonance structure because there's multiple places that that double bond could occur. So make sure you know that terminology. Resonance means there's multiple places for those bonds to take place. All right, so this is going to bend these two guys down. So this is going to be bent. Just go ahead and put 104.5 on that for the angle. And then we've got S, P1, and P2. So SP2. And this isn't perfect, but it'll do you for now. This will make sense for this now. And then in terms of polarity, definitely polar because of that pair of electrons on top. So this would be a polar covalent bond. Okay. Let's take a look at our next one then. We have nickel, chromium, and oxygen together. So there's a polyatomic here. Right there. Nickel's my metal. So this is ionic. Anytime we have a metal, we're dealing with this ionic bond here. Okay, for your knowledge, that's what we're doing. All right, so we've got to determine what nickel was used. So we have nickel. CrO4 is chromate. Okay, and then nickel does have more than one option if I look at my periodic table. So for nickel, I notice there's a 2 and 3 option. So I look up chromate and he's a -2. That's what's on the periodic table for him. So there's 1 CrO4, 1 nickel. So if this was -2, that means that was +2. So it's nickel 2 chromate. Let's see if you can see that there. Okay, and that's it. No picture, no nothing. You just had to name that one because he's ionic. Okay, the next one then, HF. Anytime we start with an H, we're dealing with an acid. So there's only 2, so it's a binary acid. So hydro for the binary acids.
Please remove your hats while you're in the building.
And then your fluoride becomes fluoric. So hydrofluoric acid is the name. Okay. These two are nonmetals, so you are still covalently bonding. It's still a molecule. So I've got 1 here, 7 here. That's 8 electrons, 4 pairs. So I'm going to go down here. 1, 2, 3, and 4. We're done. This is definitely polar. Fluorine's hogging all the electrons, so I'm going to call it polar covalent to say that, yes, they're sharing, but it's an unequal sharing. This is linear. You're looking at your 180. And in this case, we're just looking at our S.